So far in our sequences and series work, we've looked at several aspects of them. So we've looked at when you're given a rule, being able to use this rule to calculate consecutive terms based on the previous term. We've also looked at, if I give you the rule, being able to tell me if there's a limit, if the limit exists, and what the actual limit is based on the information in front of you. What we now want to have a look at is, if I tell you some terms of a sequence, can I work back the way and actually find the recurrence relation that gives me that sequence so I can use it for later terms? So that's going to be the focus of this video. Now let's set the scenario. Now imagine that you're given a sequence of numbers and you're asked to calculate much later terms. Let's say I give you the first 3 terms and I say to you, right, I want to know the rule for calculating the 100th term. What we need to do is be able to actually calculate the recurrence relation for this. So I've given you the terms, I've not given you the rule. I need to be able to calculate the rule for doing this. Now think back to the general form of the recurrence relation. We know the general form of a recurrence relation is un plus 1 equals aun plus b. It has 2 missing variables, a and b. So this one here and this one here will be missing when we have to calculate the form of the recurrence relation. Now to get these 2 things, we need 3 consecutive terms. What that will allow us to do is set up 2 equations which we can then solve simultaneously. Now remember, if you've got 2 missing variables, you need 2 equations to solve it and find them. If you've got 3 missing variables, you need 3 equations to solve it and find them. You need to make sure you understand that rule and follow it. For this, we'll need 2. So we need 3 consecutive terms to set these equations up in terms of a and b and be able to use them. Now the best way to illustrate this is with an example, and you'll see exactly what I mean. So let's imagine I've got a sequence. It's defined by un plus 1 equals aun plus b. It has 3 terms, u1 equals 4, u2 equals 3.6, and u3 equals 2.04. I want to know what the values of a and b are, and hence the form of the recurrence relation that gives this sequence. So I can start by doing this. Now, what I'm able to do is use these terms to set up 2 equations. Now, u1, to get u1, I'd need u0, the starting term, but I don't have that. However, if you think of the form here, u2 depends on what u1 was, but I have u1. So I could set up and say that u2 equals a times u1 plus b. And it's similar for u3. I know that u3 depends on what u2 is, so u3 equals a times u2 plus b. Now using the values I've got here, I could set up 2 equations. So what I could do for the first one is set up the fact that 3.6 equals 4a plus b. And then for this one across here, I can set up that 2.04 equals 3.6a plus b. So now I've set up the pair of equations here. What I'm able to do is solve these simultaneously. So think back to National 5, a pair of simultaneous equations. So I've got 4a plus b equals 3.6 and 3.6a plus b equals 2.04. Yes, there's decimals in them, but big deal. There's decimals everywhere. We have to be able to solve it. Now, if you look, the coefficient of b is the same, so I'm able to subtract the second equation from the first equation and start to solve it. So 4a take away 3.6a gives me 0.4a, b minus b is nothing, and 3.6 take away 2.04 gives me 1.56. So I know that 0.4a equals 1.56, so to get a, I have to do 1.56 divided by 0.4. If I do that, what I get as a value of a is 3.9. I'm then able to use this within one of my 2 relationships here to be able to calculate what the value of b is. Let's go to this first one here, and I'd get 4 times 3.9 plus b equals 3.6. This sets up a nice straightforward simple equation. 15.6 plus b equals 3.6, and then I can just solve it. From that, I know that b equals 3.6, take away 15.6, b is equal to negative 12. So I've got my a and my b. What I can now do is set up the recurrence relation in the form at once. So I know that un plus 1 equals a times un, but a is 3.9, so it's going to be 3.9 un plus the b, which is minus 12. So there we go. I've set up my recurrence relation for this sequence of numbers. I can now calculate the next term and continue this on. It's actually a fairly straightforward process. The biggest thing you have to be able to do is this first step, setting up the equations and then getting your simultaneous set of equations ready to solve. If you can do that, your skills from National 5, where we looked at solving simultaneous equations, will come into play, and actually it should be a fairly straightforward process from this point on.